Okay, so we have this equilibrium problem where it says for the reaction above, 3 moles of chlorine, which is that, and 4 moles of fluorine are put into a sealed 2-liter container and allowed to reach equilibrium. It's in brackets, so that means the concentration at equilibrium is found to be 0.505 molar. So we need to find the equilibrium concentrations of the reactants and the value of the equilibrium constant. So to help us organize all the information that's given to us in the problem, we're going to do something called an ICE chart. ICE stands for initial, change, and final. All of the numbers that you put in the ICE chart are either in ATM, if you're given a KP, or in molarity, if you're given a KC. Okay, so initially we don't know, well, no, that's just kidding. We know that there's 3 moles in a 2-liter container initially. 3 moles in 2 liters. So that's how I'm going to find the molarity. That molarity is 1.5. And we know 4 moles of fluorine in a 2-liter container, so that molarity is 2. And initially, they didn't put any of the product in there, so we can put 0. At equilibrium, the value of the product is found to be 0.505 molar. So what we do, the change line is always x's. Okay, so the change line has to be an x, and we see that in order for some product to be made, we had to lose some of the atoms from the reactants. So we lose X amount of chlorine. We actually lose 3X amount of fluorine. That's because for every 1 chlorine we use, we need 3 fluorines to make the ClF3, chlorine trifluoride. We gain 2X in the chlorine trifluoride. Okay, so one of the Cl2s makes 2 products. That's why we would lose X in the Cl, but we make 2X as the products. Okay, so that means that these numbers here are 1.5 molar minus X and 2 molar minus 3X. Now, here's the interesting part. Since this was 0 and this is 0.505, the change is 2x. So we can actually say 2x equals 0.505 molar. Divide by 2 and find that x equals, 0.2525 molar. We're going to carry all numbers out and round at the end. Okay, which means that the equilibrium concentration of these two would be found by saying 1.5 minus 0.2525, and this one would be found by saying 2 minus 3 times 0.2525. Okay, so that's how we find these equilibrium concentrations. Just to give you those numbers, they are 1.2475 and also 1.2425 here. Okay, so now the last part of it is that we have to find the value of the Kc, and we know from class that Kc is products over reactants. And Cl2 and F2 cubed. And so we're going to substitute into the equation at equilibrium. We're going to use the equilibrium values. So this is 0.2525 squared. This is 1.2425, and that one's cubed. And this is 1.2475, and that one doesn't have. We're going to just put that in our calculator and solve for K.